Good evening, everybody. I think everybody can hear me. Let me know if you can hear me. Just you can use the word, active, just to be sure you can hear. Just to be sure we can hear. Nobody can hear me. Hear me? Oh, great. That's nice. I hope I'm audible enough. I hope I'm audible enough. Am I audible enough? Somebody said he can't hear anything. Somebody says he can hear me already. I just want to confirm if I'm audible enough. Yeah? Let me know so I can adjust my audio from here. Oh, okay. Somebody said you can hear me clearly. What about Victor? If can you hear me clearly also? As of now. So, okay. Andy said he can hear me clearly. Okay. How about Victor? What's up? Can you hear me? No sound. Oh my God. Oh my God. Okay. Let's do this. Give me some few minutes. Let me see if the issue is from my end. Okay. Oh, Victor can hear now. All right. That's nice. Oh, network from my end. Yeah, I've actually been having some network issues. It's been weeks now. So yeah. But then I try as much as possible to ensure that the network is pretty much okay. So we don't keep having issues. So finally, everybody can hear me now, right? Correct? All right. So let's just begin. Let's just begin. So firstly, I want to welcome everybody to the first day of the yeah, it's been recorded, but unfortunately the recordings are not going to be available for now. So the reason being that we have to work on it. We have to do some editing and all of that before it's made available publicly. You might want to grab as much as possible from all of the sessions. They're going to be recorded, but I don't know how it's going to be. might not be available for free. I don't know yet. Okay, so please, I mean, it's a good time to let us know that. Please ensure you take as much notes as possible, and pay as much as attention as possible. The recordings will not be available for now, so you want to get as much as you can. Let's do that. All right. So yeah, it's going to be a 2 weeks long boot camp. Yeah, basically going to run from Monday to Fridays, right? Weekends are not going to be part. Okay, so we will definitely have some chats on WhatsApp during the weekends, right? How we're going to interact, right? So know our learning and getting understanding of the whole boot camp itself, right? But literally, Saturday and Sundays are not going to be for trainings, right? So our trainings is just going to be Mondays through Friday this week, and also Mondays through Friday. Promise us we're going to cover everything that we need to know on solar design and stuff. Promise us. Right? I'm going to touch, you know, as in depth as possible, depending on how much we can take in, right? I wouldn't want to stress us regarding some of the technicalities also, but if I see that we actually can take in some of those technicalities, then I'll go as possible. I promise us, I'll give us, you know, all of the understanding that we begin our career in solar design. Once again, I want to welcome us to this training. I believe we're going to have a smooth ride, and we're going to enjoy everything. Right? So just before we get started, I'd like to make an apology. It's been, you know, back to back. No, you're not late. You're not late. We're just getting started, right? So yeah, it's been back to back work for me, trying to put all of these things together. Pardon me today, right? I omitted my slide. Okay, so I didn't prepare my slide. Even though I have my series or, you know, worked on. As a matter of fact, I try to look for it just before, you know, this training starts. I can't find it anymore, and that's just the truth. I tried looking for it. I just could not find it anymore. So I don't know why. I've looked for it. You know, I kept it somewhere. I searched my laptop. I could not get it. So just permit me for just this night. I promise you, it won't happen subsequently. I'm going to get my slide. It's going to be beautiful. So we're going to work with, you know, what we have. But pretty much our coverage today is just going to be introducing us to solar installation, and solar, whatever, solar, everything solar, right? Just about the whole, what's it called? The whole thing, not necessarily everything, but, you know, just about information around it. That's basically what I'm going to today. So yeah, that's what we're going to be doing today, and I'm going to be talking also, you know, how we can. I know a lot of us are students, and we basically, you know, are still in school. Some of us are already are in the field. Some of us are, you know, doing electrical stuff already, and some of us are looking to venture. We could take a career switch, you know, and all of that. So I'm going to also be explaining to us how, you know, we can incorporate all of this. I believe it's going to be a good way for us to. That's before we even go into, you know, the details about solar. So give me some seconds. All right, so let's talk about solar in general. Solar in general. Of course, I'm sure, you know, every one of us here is familiar, solar, like you must have heard, somebody says solar, solar here, solar there. And somebody say, that's what it's raining now, solar, right? I mean, of course, it's a beautiful, how will I say now? It's a beautiful thing. You actually know all that you're meant to know regarding this stuff. First thing I want to say is that not something that it's that hard like we expect, right? Matter of fact, solar design and installation is not hard as you might have expected it to be, right? If at all we expect that, it's going to be hard and all of that, right? So now, when we talk about solar, we're talking about first, solar means anything that has to do with the sun. We're looking at harnessing, right? We're looking at harnessing power or the energy. That's basically what the systems or the technology of harnessing the energy, right, that comes from the sun. Okay, so over the years, there's been a lot of ways where a lot of people have tried to harness the power from the sun. Right, there's been a lot of working behind the scenes that people have done, and we also have to appreciate it. Okay? We have to understand that a lot of people have worked in order for us to get to where we are today. So, in harnessing the power of the sun, right, there are some. Trying to share my screen now. In harnessing the power of the sun, there are some things that we need to consider, right? There are some things we need to consider, and I'm just going to be. I hope we can see what I posted for us. Our coverage tonight. Hopefully, we'll be able to cover all of those tonight. I know we started so late already. Sorry about that. It's a lot of work to pull all of this. All right. So I was saying that there's a lot of systems that are put in place, right, in order for us to harness the power of the sun. And that is why you have all of the technicalities and the complexities that comes with solar systems, right? So you have the solar panel, you have the inverter, you have the charge controller, you have quite a number of components, right? All of them are in an attempt to efficiently harness the power of the sun, right? And now the power of the sun is basically converted into electricity, right? And for us to understand what electricity is simply the flow, right, of electron, right? And what is electron? Electron is what you get when you break any material, right, down into their simplest form, right? Many of us went to secondary school, so you must have been taught atom, and they tell you atom is the smallest and indivisible part of an element. That's an obsolete definition, but for the sake of today's class, we're going to stick with it, right? Because when you break down atom itself, atom also has some particles, and we also taught particulate nature of atom, right? And if you break down materials, all right, take any material, let's say plastic material or aluminum material, and then you break them down, what you're going to get is the elements, right? The elements means that by the time you're looking at that material and you pick one thing out of that material that you have broken down, what you get is an element. An element is the only, how will I say it now? The only thing that exists, all right? So let's say you have a wooden material, for instance. Inside that wooden material, you might have some dust, right? You might have, maybe they have painted it. You understand? You might have some other, chemical combination inside the wood material. You understand? We call it material because that wood is not just wood that is present, right? You have wood plus water, moisture, paint, whatever, right? But when you remove all of the water, moisture, everything from the wood, and you only have wood left, and then you begin to break that wood down, you break it into 100 pieces, break it to 1,000 pieces, break it down into 1,000,000 pieces, break it down into, 1,000,000,000 pieces, and you break it to the point where you can no longer break it down. Right? That's called an atom. So when you pick out one of those pieces out, you are just picking an atom, right? And by the time you now pick that one pieces, which we now call an atom, now you break it down also, you are going to find electron inside, right? That is where electron comes from. Now, that electron, whatever you do, make that electron move from one point to another is what you call electricity. I hope we're getting it, right? So I said I was going to, I'm going to start this way to see our reception. If I feel like, it's a little bit too complex for us, then I'm going to just put it down, right? So that's where electron comes from, right? Electron is basically present in everything you can imagine, even you, your body, right? It's present in everything, and whatever it is that you can do to make that electron move from one point to another, you have successfully generated electricity, right? And so you now know that nobody created electricity. It has always been what? It has always been there. We only found a way to what? Channel it. We only find a way to increase it. We only find a way to make it available for everybody to use. I hope that makes sense. Now, coming back to harnessing the power of the sun to generate electricity, which is what we do with solar panels, right? So you use the energy from the sun. That energy is used to empower electrons inside the solar cells. And once that happens, the electrons begins to move from one point to another, and that causes electricity, right? That is basically what generates electricity inside your solar panel. All right, let me know if we're getting it before I continue, right? Let me just know if we're getting it before I continue. There is a little bit of latency. Transmission, right? Transmitting from Zoom over to YouTube. Tomorrow I'm not going to do that because of the latency, so that I can have direct live feed and all of that. Right? But we'll just wait a bit. Are we getting it? Are we getting it? Okay, we're getting it. All right, cool. All right. So now, yeah, perfect. Thank you. Okay. So we already established that the energy that we harness, right? Literally, we're not creating anything, right? We're only harnessing what? Everything. Okay? And of course, compared to all other sources of energy, right? Or all other sources of electricity, solar seems to be more environmental friendly, right? Also, it's abundant, right? Because we're only using the sun that is pretty much available everywhere, right? And it's a renewable energy, which means you don't just use it up. It can also be available for you to use tomorrow, right? So the sun is up today, your solar panel is working. By the time the sun is up tomorrow, it will still work, right? That's what we mean by it's renewable. It's a renewable energy. And on top of all of that, it's eco-friendly, it's environmental friendly. What that means is that if you're using generator, right, you're using pretty much generator or nuclear fission or fusion, whatever, you tend to generate a lot of substance that are harmful to your environment, right? You must have heard of the depletion of the ozone layer, which is a result of fossil fuels, right? It's a result of fossil fuels that we burn, right? If you burn kerosene, for instance, or you burn PMS, which is petrol, or you burn diesel, right? The result or how will I say it now? All of the fumes that you see that is going everywhere when you're burning something, is CO, carbon monoxide, and that carbon monoxide, is not friendly both to humans, to our environment, and even the ozone layer, right? So over the years, all of the energies that we have used from fossil fuels so far has actually depleted our ozone layer and made our environment to be even more toxic, right? And that is why it's safer to live in rural areas than to live in urban areas, because in urban areas you have factories, you have a lot of companies that are running on fossil fuels, are burning fuels that are dangerous to human health, all right? But for solar energy, you don't have all of those challenges, right? It's a very pure energy from the sun. There is no CO. It has a very minimal CO emission, right? And that's what makes it to be very environmental friendly. Even around the world globally, nations and country governments are clamoring for the switch to solar energy, and that is why as a matter of fact, in Nigeria here especially, solar energy is still pretty much premature. What that means is that it's in its developmental state, right? I mean, a lot of people, there's still a lot of work to be done regarding solar energy, right? There's a lot of people that are not using it right now that will still use it in times to come. I mean, there's a lot of, and on top of that, solar systems, the components are getting, lesser in terms of the cost every day, right? So there's a tendency that a lot of people still move into this system, and you stand a lot of chance all of this, right? So yeah, having understood that, I also would want us to understand what we mean by solar radiation. Just going to be talking about the key terms that we should understand, so that by the time we proceed in the course, it's much more easier for us. Okay, so solar radiation, right? Solar radiation, basically, that is the energy that is coming from the sun, and that energy is in form of electromagnetic waves, right? Because it's the light that you see around you. That's what it means, right? The light that you see around you, the ones that you cannot even see, the infrared radiation that comes directly from the sun, that is what heats your solar panel and generates electricity. Okay, so yeah, so solar radiation is the primary driver of Earth's climate and weather systems, right? So depending on the radiation that you have every day will determine the kind of weather that you have and kind of the climate that you're going to have that day, right? So, and this energy can be measured, right? And this is why solar energy is very, very lucrative, right? We have it in abundance. Okay? We have it in abundance. For instance, now, if you place, if you create a space, let's say a 1 square meter space, right? 1 square meter space, you don't know what the 1 square meter space look like. You can Google it up. Maybe when we're done with the class, I don't know. Maybe you can even check it right now, right? If you create a 1 square meter space, that 1 square meter has a tendency to generate up to 1,361 watts of power, right? That square meter space has a tendency to generate up to 1,361 watts of power, right? Just within that square meter, right? And an average panel that you see around on roofs is way more than 1 square meter. So you can imagine how much a panel can actually generate, right? Even though we're not able to capture all of this 1,361 watts, in particular, depending on the size of the panel anyways. But if you get a 1 square meter panel, you won't be able to capture 1,361 watts of power, right? So, but then, there are different sizes of panel, right? There are different sizes of panel from the small one, from the 5 watts panel, the biggest one, which is around, that I've seen 610 watts, right? You have even more than that. Okay? Let me know if I'm still making sense. Am I still making sense? Am I still making sense? Okay. So yeah, we have it in abundance, right? We have it in abundance. And also, depending on your location, or depending on the parts where you are in the world, right? That will also determine how much of solar radiation that you're going to get. For instance, in the northern part of Nigeria, okay, you could get more than people who stay in the southern part, right? Because it tends to be very hot, the northern part of Nigeria, than the south, even in dry season. So regions, okay, also play a role in how much of solar radiation you get at the time and all of that. So, but on the average, you can get about 3 points. On an average daily, you could get about 3.5 kilowatts of energy on a square meter within a single day, right? On an average, whether you're in the northern part of Nigeria, northern part or southern part, right? As a matter of fact, in the southern part, you could get up to some 3.5 kilowatts of power, right, within a square meter per day, right? Remember, I said that you could get up to 1,361 watts per square meter, right? But after a day, right, has ended, you should be able to get up to 3.5 kilowatt of power within a square meter. And you can even more than that in the northern region. You can get up to 7 kilowatts. You can get up to 7 kilowatts per square meter. Northern region. So solar energy can be used for a wide range of applications. Of course, Victor, seems like you're affected by your network. What are we going to do to your network? Somebody said it's just you. Okay. Please, Victor, find a way to fix your network. I don't know, maybe you switch to, if you're using Airtel, you could switch to MTN. Also has to switch to MTN this evening. Give a maximum. So if you can also do that, also, it's going to be nice, right? So I'm just pretty much explaining to us solar energy and solar irrigation, and then I'm extending it to its availability in Nigeria. And now I want to begin to talk about the application. Okay. So yeah, solar energy can be used in a variety of applications, from your day-to-day appliances that you use, right, to even heavy appliances, from residential application to commercial application to even industrial applications. Right? Industries have solar panels just help them facilitate their processes. So yeah, rural communities, urban communities, there's a lot of applications for solar. As a matter of fact, solar can be used to power pretty much anything that you want to power. That's just the truth. Solar energy can be used to power anything that you might want to power. So that day-to-day gadgets, to even your pumping machine at home, to using it in the kitchen, like for instance, your gas cooker, your electric cookers, microwave oven, ACs, pretty much anything that you want to do. Solar energy can be harnessed to do all of those. And that's the beautiful thing about it. And there's actually no limit to how much of solar energy you might want to have, right? We have solar energy ranging from some kilowatts, right? Some kilowatts to megawatts, right? You have solar energy, in industrial scale. For instance, if you go to China, I think China generates up to about 35 megawatts of energy on a yearly basis. Now on a yearly basis, but they use a lot of solar energy right there. And even if you take a statistics of how much of solar energy we use in Nigeria year to day, it's running in megawatts already. So the application is very vast. It can pretty much be used anything that we do. All right. So also we have to be aware of some of the challenges using solar systems. First, and this is what scares people the most, right? Is the cost, right? The cost of establishing solar systems, right? It's expensive, right? Not so much expensive, depending on what you want to do. Yeah, but starting capital is expensive. Yeah, And in some cases, which is very rare, is lack of infrastructure, right? Which is very, very rare, because now we have sophisticated solar systems. Inverters now are smart. Even your batteries now are smart. Understand? So we have a lot of infrastructures when it comes to solar systems. Okay. So yeah, there are also government initiatives and government policies, right? Especially in the area of mini grids, right? Mini grids is when you want to set up a solar system for commercial purposes. Right? Say, for instance, you have a shopping mall and you want to power up the shopping mall. So instead of just relying on public supply like PHCN or power holding companies, we want to also have an alternative supply, and we could set that up as a business, and people can pay for that. So they'll go to a complex or go to rural communities and set up like a solar station and distribute power to people. A lot of people can get power the same way the NEPA people will give power to people. You can establish that, and that's called mini grid anyways. And so and there's a lot of government policies around this particular one that actually limits the mini grid. So those are just some of the limitations around solar system. Okay. So before I go ahead, does anybody have any question? Oh, Victor, you didn't miss anything. You didn't really miss anything. So question, anybody? Question before we go on? Or just if you have any question, drop it on the chat. I'll see. So right. Let's continue. Yeah. So next, we'll move on to that's supposed to be photovoltaic. All right. Yeah, photovoltaic technology and solar cell. Again, I just have to apologize for not presenting my slides today. Promise us, tomorrow is not going to be like that. So I'll have to do another one though. All right. So let's talk about photovoltaic technology and solar cells. What do you mean by photovoltaic? Photo basically means photo means light, okay? And voltaic means a system where light can be used to generate voltage. Right? That's basically what the photovoltaic, right? System whereby light is used to generate. So basically, this technology converts sunlight directly to electricity using the photovoltaic effect, right? So photovoltaic effect is how light can be used to generate or induce voltage. Okay? So yeah, that's the photovoltaic effect. And solar cells is different from solar cells, right? Photovoltaic is that technology that uses light to generate electricity. Okay? Solar cells are materials, right? Usually semiconductor material like silicon, and they are that substance upon which the light falls, right? And it now generates electricity. Okay, so photovoltaic is that system. Okay, solar cells is the material upon which the energy from the sun falls upon, and inside them is where the electricity is being generated. Inside the solar cells, and that's where all of the processes happen. Okay, so when solar cells are exposed to sunlight, okay, they generate electricity. Solar cells are made up of silicon. Right? That silicon is one of the semiconductor. I mean, yes, semiconductor material that is pretty much abundance, especially here in Africa. Right. So yeah, let me show us. Let me see if I can get a picture of what I mean by solar cell. Cells. I will know what I'm sure most of us would have seen it. that blue stuff that you see on solar panel, all right, that blue stuff is used to have line. Yeah, that's the solar cells, right? And you don't have one of them. Okay. Yeah, this is very good one. Yeah, can we see that? That's a solar cell. So that's pretty much what you're going to see inside the solar panel. This is it. So this is what you're going to see on the solar panel. And those are called solar cells. Now they're made of silicon, right? And that is where the sun energy will fall upon, right? So once this solar cell is exposed to light, okay, it generates electricity. How that works is a little bit of study on semiconductor. Right? Going to understand how that's especially maybe if you have time, go and learn on what is effect. Okay, so light falls on this solar cell and it generates electricity. That's just it, right? Now you don't just have one of these present in the solar. You can have up to, I think you can have, yeah, depending on the size of the panel, you can have up to 32, 64, right? And depending on the size of each solar cells also, you can have up to 64, even more than that, all right? Samuel Richard, you're saying there's no audio. I'm not sure. Can everybody hear me? Please let me know if people can hear me. Can you hear me? Can you hear me? Let me know if you can hear, please. I need a response. Okay. Yeah. Samuel Richard, I think you issue my most likely is from you. Most likely. All right. So let's just continue. Hopefully it fixes that. All right. Where did I stop? Talking about solar cells. So you have a number of them on single solar panel, and each of the solar cells are connected together to form a whole, right? So each of the solar cells can generate maybe some 0.5 volts. You can be surprised that they just generate tiny amount of voltages, but they are connected together in series to increase their voltage. We are going to be learning all that because of the so a lot of them are connected together in series to increase the voltage and ultimately give you so those are solar cells, right? Those are solar cells. So you have pretty much three types of them. You have the monocrystalline solar cells. You have the polycrystalline. You have the thin film solar cells. So and the monocrystalline is the best, right? It has the highest efficiency and has a longer or the longest lifespan. Okay, so yeah, it has the highest efficiency and the longest lifespan, right? So and pretty much what you're going to find in the market, monocrystalline. Yeah, monocrystalline. There used to be polycrystalline in those days, right? But they are not really common in the market. People go for what is quality and what is most efficient, right? So yeah, you have the polycrystalline, which is lower in cost, but it's slightly less efficient than the monocrystalline. We also have the thin film solar cells. These are more flexible, right? They're not as rigid as those refers to, but they are less efficient compared to. So those are the types of, and there's not really a physical way whereby you can actually identify which one is monocrystalline, which one is polycrystalline, which one is thin film, right? You just have to check the label on the solar panel. The manufacturer will indicate on the label of the solar panel, let you know that this is monocrystalline or polycrystalline or thin film, right? So the manufacturer will let you know, right? Yeah, that's how you know. But when you go to the market, always go for the best. Buy monocrystalline. There's no point buying low quality. Sure, you buy the monocrystalline always. Yeah. Pretty much about all of that. We can now begin to talk about PV systems. PV system. Samuel Richard, what do we do with your, what do we do with your this thing? Okay, not sure I'm doing a summary, but I've said I will share the with us. So I think it might be a network problem somewhere. I mean, yeah, it might be a network problem. So you might want to try and fix the network problem. Most likely might be a network problem. Maybe your audio devices. All right. So let's just continue. This yeah, maybe you try and maybe you try and all right. So yeah, let's talk about PV systems. PV systems. A lot of us are familiar with PV systems already. So yeah, photovoltaic systems. Of course, your popular solar panel, inverters, mount structures, batteries, charge controllers, and so on. Okay. So we're going to talk about all of them one after the other, just for you to be aware of PV system components. Yeah. One of the most important things about the solar panel is the efficiency of the solar panel. This is very critical because solar systems are very expensive. And you don't want to buy something for your customer, right? And person ends up, after you have spent, let's say, 10 million or 20 million, installing this whole system, and it's not providing, or is not, providing energy sufficiently or efficiently. I mean, you don't want to be in that mess, right? That is why when it comes to solar design and installation, you have to be very careful. You really have to be very careful. And much more than how much you're going to get from projects, you have to always ensure you do qualitative work. As a matter of fact, the way you have to be detailed when it comes to solar system, up to the size of wire, the type of breakers that you use, you really have to be careful, because any mismatch, right, can disrupt the whole system. So imagine somebody has spent 5 million, 10 million naira, and is having issues because you didn't use the right size of wire, and that really can be an issue. So when it comes to solar systems, you really have to be careful. Screen sharing is paused. Really have to be very careful. Really have to be very careful what you use. Very important. Very important. All right. So now, you have to understand efficiency in solar panels, and not just in solar panels, pretty much all of the components that you're going to be working with. Right? From the cables, to the charge controller, to the inverter, to the battery, to the solar panel. You have to know their efficiency. Because you have to be able to estimate using their efficiency. You have to be able to tell the client, this solar system will be able to deliver to you this amount of power and energy per day. And the client wants to get exactly that or more, not less. Exactly that or more. Right? So solar panels have, their efficiency, and the efficiency is usually between 15% to 22%. Right? That seems to be low. That seems to that sounds very low, right? But the efficiency is not in terms of the solar panel itself. It's in terms of how much of energy we can get from the sun versus how much we can harness with our solar panel, right? So yeah, that is not like maybe the efficiency of the solar panel is 15%. We're saying that how much can this solar panel convert the energy from the sun to electricity, right? And that's usually between 15 to 22% efficiency. But the solar panel itself, can have up to some 85, 95% efficiency, right? Even though by the time we're doing our calculation, we don't use up to that amount, right? Because most of the solar panels we buy in the market are not actually more than some 65 to 75% efficiency. Even though there are solar panels that are really very efficient, even up to 90% efficiency, but they are more expensive than themselves, all right? And also depends on the manufacturers, right? Depending on, so that is the efficiency of the solar panel. But when we talk about the efficiency of the conversion of the energy from the sun to the solar panel itself, we talk about from 15 to 22% efficiency, right? Which is pretty much okay, right? It's pretty much okay. But the solar panel itself, has, should have high converting efficiency and everything like that. So when we're doing our calculations, we usually work with around 65 to 75% efficiency with our solar panels, right? Because that's just to be safe as an installer. That you don't under deliver. So yeah. So there are some characteristics of PV, that's solar panels, that's PV modules that you are going to see. You go to the market to buy a PV module, that's solar panel, you are going to see some details at the back of it, right? Those are the manufacturer's details for you, right? Some of the details you're going to see are going to involve current rating of the panel, maximum voltage, the maximum current that the panel can deliver, the maximum power that it can deliver. You're going to see the short circuit current, which will enable you to know the size of breaker to buy, and some of those information we're going to talk about them when we get to treat solar panel sizing properly. So now, yeah. So another thing you want to know about solar panel is how they are affected by temperature. Solar panels are affected by temperature. The higher the temperature, the lower the conversion ratio of the solar panel. What that means is that if the sun is extremely hot, solar panel gets hot, and that reduces the performance of that solar panel. That means the conversion rate, the conversion efficiency reduces. Right? So I know we generally say that solar panel needs the sun to generate electricity. But what we mean by that is the radiation I've explained to us before that is coming from the solar energy. Solar from the sun, not necessarily the heat, right? It's the radiation. And even though the radiation can be associated with how intense the sun is burning also, all right? But primarily, the conversion is a result of the radiation from the sun, not necessarily the temperature, right? As the temperature goes higher, the performance of the panel also reduces, even though it's not really significant. I think it's about 0.5 0.5%, 0 to 0.5 or 0.0 something. Okay, maybe I will check that out, but it's not really significant, right? It's not really significant compared to trying to check that out for us. So, even though it's not really significant, right, but something that if you're designing on a very large scale, right, it can be very significant because now you have, hundreds of kilowatts of panels. Now it becomes very significant, right? And that's why you have to understand this. That, the more the more the temperature, right, the less it converts your solar energy to electricity. If that makes sense. So yeah. So we've talked a lot on solar systems, photovoltaics, solar radiation today, and just to do a little bit of recap for us, we've talked about solar energy, how it's all about harnessing the energy that is coming from the sun. Talked about solar radiation, how that's is different when we move from region to region across the world. Talked about photovoltaic systems. Talk about solar cells, how they help convert from they help convert solar energy into electricity use. Yeah, I think we before we just before we round up, anybody has any question? Today is just for a bit of introduction, because tomorrow we're going to get into the course proper. So most likely tomorrow is going to be for a safety class. All right. So before we round up, anybody has any question? Somebody else is going to be handling tomorrow's class, most likely on safety, right? Safety is very important. From general safety, it's going to be taking us on general safety, basically. While as the course progresses, I'm going to be taking us on part of the safety. Right? So having said all of that, do you have any question? Question? All right. So if there is none, we'll call it a night. Please let's ensure we can try to research more concerning everything I've said tonight, so that we have more in-depth knowledge. That's pretty much everything basic around solar systems, solar energy. So yeah, we started a bit late today, and that won't happen tomorrow. There's a lot of setting up that. So again, the attendance is not really encouraging. I don't know. We have about 100 plus on the group chat, so I expected even more than this. At least I expected about half of us to be around. Please, we will find a way to motivate our others on the group chats and all of that. Please, if you enjoy the class, kindly go on the group chats, not just on the group chat, even on the comment section. Kindly comment one thing that you learned on the call tonight. Right? If you can do that on the Telegram, you can do that on the WhatsApp, and also on the YouTube right now. Kindly comment what you learned today, and kindly comment what you learned today. Group chats, Telegram, WhatsApp, YouTube, whatever. Just kindly one thing that you learned today in class. Also, if the time was worth it. But so yeah, without more further ado, we just bring the class to close tonight. I'll see you tomorrow by God's grace. I hope you enjoy the rest of it.